In the last video, we talked about evaluating limits graphically and using tables. However, in this video, we'll be taking more of an algebraic approach. First, we need to establish some basic limits. The first is that the limit of a constant will just be that constant. This makes intuitive sense because a constant represents a straight line, and it's impossible for a function to stray from that constant. The second is that the limit of the function f of x is equal to x will just be equal to the x value that the limit is approaching. For example, the limit of x as x approaches 3 will just be 3. Finally, if we raise both sides of the previous limit, we get this final property that the limit of x to the n, where n is an arbitrary positive integer, as x approaches an arbitrary value c, will just be equal to that constant c to the n power. For example, the limit as x approaches 3 of x squared is equal to c squared, or 9. Now that we have these basic properties down, here are a few more that are helpful when evaluating limits. While there are quite a few of them, they aren't too difficult to memorize, and you may see a pattern surrounding each of them. Also, here are a few more. For these ones, there are several restrictions to prevent zero denominators or negative square roots, but in general, it's the same pattern. Alright, now that we have the hard part out of the way, let's do some examples. Say, for example, that we want to find the limit of this big expression on the screen as x approaches 3. First, let's split the numerator and denominator using our limit laws. We can use our limit laws to break the expression up, as so, using our addition and subtraction laws. Then, we can pull out the constants from the 5x squared term and the 2x squared term. And finally, we are left with a combination of simpler limits, which we can easily evaluate. Doing so, we arrive at the answer of -1. So, as you can see, evaluating limits isn't too difficult once you get the hang of these limit properties. Let's try one more example. So we have this function on screen, and we want to figure out the limit as x approaches -5. This time, pause and see if you can figure out the problem yourself. Okay, so first, I'm going to use our limit property involving radicals to put the limit inside the radical. Next, I will split the expression up using our subtraction property and take out the constant in front of our x squared term. Then, I'll use the division rule to split up the fraction in the second term. Finally, the last step is to evaluate the limit, and we get the square root of 249 over 5, or about 7.057. We'll talk more about continuity later, but one more note. If a function is continuous, informally it means that there are no holes or gaps in the function's graph. Generally, this allows us to just plug in our value of c into the function to get our limit. This technique is called direct substitution. The other techniques, however, will still be useful as we get into the later episodes. Alright, that's it for this video. If you have any questions, feel free to email me at lowqualitymathematics@gmail.com. Let's do some more math in the next video.